the full power of the capital markets can converge. But right now, if I look at what's actually been achieved with real-world assets so far, there's so much further we can go. It's almost as if there's It's almost as if there's kind of like an impedance mismatch. There's all these assets that could be brought on chain, whether they're bonds or equities or funds or whatever they are. But just because they can be brought on chain doesn't mean anybody on chain will actually want to buy them. And that's perhaps not surprising. If those of us in this room who've lived on this ecosystem, we're used to better. We're used to what the on-chain markets can provide. We're used to being able to access assets anywhere in the world in any ticket size with instant liquidity, even if the underlying asset is illiquid, with yield that is actually commensurate with the risk we're taking. But there's an impedance mismatch. That's typically not what's being supplied. Now, of course, that's also a solved problem. That problem was solved in the traditional financial markets by a little technology invented, depending on who you ask, maybe 101 years ago, the mutual fund. That's the solution to this problem. You've got some assets that aren't quite right for what the investors want. You package them up in the mutual fund world in a legal structure with perhaps a layer of liquidity or a layer of structuring, so that what pops out the other side is exactly what the investor wants. But it's slow, it's clunky, it's a centuries-old technology, it's expensive, and it doesn't do a good job particularly for anybody. But there is a solution. There's a direct parallel in DeFi. It's the yield vault. It's an on-chain contract, very cheap, very quick, very easy to write, that does exactly the same thing, but permissionlessly on a network, on a permissionless network. You can own the underlying assets, and then with a curator, think of it as a fund manager, they can then mix the assets in the right form, with the right liquidity, with the right liquidation profile for the underlying investor. So that's the missing piece, if you like. That's the way to bridge this impedance mismatch. So this isn't a technical problem. This isn't a software engineering problem. If you like, it's a financial engineering problem, If we could somehow transform the assets from what are being supplied off-chain into what's demanded on-chain, suddenly we can unlock explosive growth in the availability of real-world assets, and hence complete those internet capital markets, move it from being, say, something of a marketing term to being something that is a genuine description of what can be achieved, and can be achieved solely on Solana, going back to that point about it being a single shared, massively performant substrate, rather than a collection of satellite L2s and private networks. So that's what R3 is bringing to market. So R3 Labs, early next year, will be launching the real-world asset marketplace for Solana, a single unified place where off-chain traditional issuers can issue their assets in a way that will in a way that will give them distribution directly into these on-chain vaults that are curated by a collection of high-quality curators who can turn these assets into a form that the on-chain investors actually want to and actually can buy, and importantly, can then connect directly into the DeFi ecosystem. So that bridging of the world, giving the asset issuers what they want, which is distribution in the right form to what the people on-chain want, which is assets that actually meet their needs with the right access profile, the right liquidity profile, and the right yield. It sounds so simple, it sounds so easy, because it has been achieved to some extent, albeit very imperfectly on the traditional side. What we're doing is bringing it onto Solana to be the on-chain real-world asset marketplace. So there's a lot more to talk about. If you want to be one of the first to give this a try, make sure you register at corda.xyz or go to enter your Solflare Quest code there. But just to finish, real-world asset marketplace can only be done on Solana because of Solana's unique architecture. We chose Solana as the representative of a huge amount of TradFi for a reason, and I haven't regretted that choice once. So thanks very much for your time, and I'll speak to anyone afterwards. Thank you. Yes.
Thank you for that. Well, everybody, I'm going to be taking off and leaving you for now. We are going to take a short break. Next session will start at 3:50. Look forward to seeing you then.
Your MC.
Hello, everyone. Welcome to Dev Day. It's a great honor to be your MC this morning. My name is Steve Schonebeek, and I'm the business developer at Trident One. I hope you all came well rested. We have a packed schedule for you. But first, a word from our head of product at Solana. Please make some noise for Solomon.
Thank you. Thanks. Hey everyone, hope you're having a great second day at Breakpoint early in the morning. I'm Solomon. I'm a product engineer at the Solana Foundation, and I'm super excited to bring to you day 2 at the dev stage. This is my third Breakpoint. It's been really great to walk around and see so many new faces, so many familiar ones, and to see all of these ecosystem activations around the venue. There's some really solid ones that are very fun, unique, and quirky, so please make sure to go through the entire venue and see everything that's happening around. For today, I wanted to do a quick intro on why we're here in the first place, and then go through some logistics for the rest of the day. So a year prior, we used to have a lot of developer-focused events called hacker houses. Hacker houses were these sort of event venues maintained by the Solana Foundation to allow developers from across the world to congregate in certain areas to dive deep into certain technical topics and applications. And unfortunately, hackathons do exist, but hacker houses in their old form do not. And we got a lot of feedback from many developers in the ecosystem, basically saying, hey, we really want more serendipity. We want more of these events to talk about what we actually care about, which are these deep technical topics that typically you won't find at these events where it's mainly product, marketing, sales, and BD. And so we thought really hard. We didn't want to basically recreate what we had in the past, but we wanted to make sure that no matter where we're showing up across the world, that we would still have these events that are tailored towards the audience that they should be for. And so beginning of the year, in May, we actually had the first version of a new type of event called Accelerate. Accelerate was during May in sunny New York. And we basically wanted to recreate a new type of event that was at the time mostly focused on finance, policy, and regulation, but we also wanted to have a separate event primarily for tech. And so we had this week-long event, and at the beginning we had a very specific event for the developers, which was called Scale or Die. And Scale or Die was my baby. It was a really awesome event, and a lot of people had really great things to say. The outcomes were very clear. We wanted all the developers in one place to dive deep into really important ideas across core dev, across security, across infrastructure, and we did exactly that. We actually got a lot of really rave reviews. Developers and teams would come up to me and say, hey, this was one of the best events I've ever been to, because they were able to congregate around specific topics that only mattered to them. And so as a result, we were like, okay, well, we should have developer events at every venue that we're showing up at. And so here at the Dev Day at Breakpoint, we wanted to basically reinvigorate the developer community and make sure that we had talking points and an event for you guys. And so today we're going to have a lot of really awesome talks across security, across infrastructure. We're going to have a really interesting block with Fire Dancer called One Fire Dancer, where they'll talk about Fire Dancer on mainnet and accruing more stake. We'll have Onza have their own block of talks, primarily focused on performance and IBRL at all costs. And then we'll have some things like Anchor and 1.0 and some other pieces across the stage. So I'm really excited to bring the Dev Day to you. For logistics, all talks today are actually only 10 minutes or 15-minute talks. Usually at dev stages, we try not to do fireside chats or panels. We want to get deep into the actual content and make sure that people are learning net new things and are sort of getting new information that they usually wouldn't have. It's available for everyone. It'll be live streamed and recorded, and so I'm really excited to have this developer-focused day to make sure that we're all reinvigorating the tech, and next year we'll focus on developers and distribution. Thank you.
Thank you, Solomon. All right, to kick things off straight away, Please put your hands together for the CEO of Chorus One, which is one of the leading staking solutions for institutions. Give a big round of applause for Brian Crane.
How do you change the slides? Is there a... Thank you. Cool. Well, thanks so much for coming. I appreciate you being here. I think there's some competition somewhere else for this talk, so thank you so much. So yeah, so the Solana vision, right, is basically to create this internet capital markets where you can have people from all over the world create applications, transact with each other, potentially accommodate all kinds of economic activity. But for that to happen, right, the network underneath also needs to perform at a certain level. So today I want to look at a bit where is Solana right now in terms of its performance and capacities, and what are the main changes that are coming up that really will get this network to the place where it's sort of fit for the Solana vision. So yeah, briefly about ourselves. So we've been deeply involved in Solana since the very beginning. Met Toli and Raj in like 2018, invested in Solana. We were there at the very first testnets. We were Genesis validator. Helped also patch a bunch of vulnerabilities before mainnet, including one that allowed someone to mint lots of Solana. We built the first liquid staking solution on Solana that didn't end up surviving, but we did a bunch of the first MEV research. And today we run a whole bunch of different validators, and we do a lot of quantitative experiments as well, where we measure performance and compare different configurations, and we'll talk a bit about that. So first of all, high level, where is Solana today? So we have seen Solana really improve tremendously in the last years. Even from the beginning, Solana had these ideas of 400 millisecond block times, but it wasn't the reality for years. It really was like 600 milliseconds, 500 milliseconds, and it took years to get us to the point where actually the network, if you look at this year, was really consistently below those 400 millisecond target. So tremendous improvement on that side. We've also had skip rate, right? In the past, we had a lot of issues with stability, blocks being skipped, downtime as well. So that has gotten way better, and today, skipping blocks has become a rare event. And of course, Solana has consistently high economic activity, a lot of transactions. So I think today it's around 400 transactions from users, right, per block. And it's definitely probably the most used of all of the blockchains in terms of economic activity happening. But there's challenges as well. So at the moment, right, the economic activity on Solana is at the low point in the last 2 years. So MEV and priority fees are pretty low. You can see this chart here. And of course, we had a crazy boom earlier this year, sort of with the whole meme coins, Trump. There was an enormous amount, like the most ever. But now it's retrieved a lot. And that creates a lot of challenges, including pressure on validator earnings and, yeah. And one of the most interesting things happening right now is that we're seeing this explosion of custom schedulers. So maybe it's worth talking a little bit about what that is and why it matters. So if a validator is up there and producing a block, they have a certain amount of time and they receive lots of transactions, and in that time they can process these transactions. And they can do this in different ways. And but in the past, nobody really did that. There was just a default software, and it produced.
The folks here, I'm just going to kick stuff off and cover things at a high level. So as you all know, at Onza, we're heavily involved in steering core protocol development. Most notably, we build the Agave client. And during the next 9.5 minutes, we're going to go on a journey and recap a few exciting wins, but more importantly, illuminate the path of where we're taking the protocol. And we'll structure things by talking about these categories on the screen one at a time. And we'll start with resiliency. So that's almost 2 years of solid green liveness, around 200 billion transactions. And the message is Solana stays up, right? And it keeps servicing transactions. And that's been the case for a long time now. And I think October 10th really served as a proof point of just the level of maturity of the Agave client, but also the Solana ecosystem and its ability to handle immense transaction load and keep packing thousands of user transactions per second. And through all of this, we've kept the Agave quarterly releases rolling out like clockwork. The 3.1 release is coming up next before 4.0 brings a bunch of new exciting fun stuff in the new year. And the reason we're able to keep this aggressive cadence is because of the immense stress testing and red teaming that we perform. The invalidator team at Onza is attacking the public testnet with a unique set of attacks triggering every hour. And we haven't been super open with what this team does for what I assume are obvious reasons, but we've fixed enough of the problems at this point that I think we can give this team a little bit of shine. So the attacks mostly fall into two categories. We've got network DOS attacks, and we're stressing load shedding, back pressure handling, things of that nature. And the second bucket is these highly curated blocks packing with super strange transactions, stressing the far corners of the SVM and replay execution. And this graph just shows our malicious testnet nodes cycling through those attacks. Here's an example of a malicious node hosing down a bunch of the other nodes with gigabits per second of network traffic, but the network was still screaming along, making blocks on time, tower height steady at 32, all the things we want. But this wasn't always the case, right? We used to be able to make nodes crash, then we got a little better, then we could disrupt nodes, then we got a little more better, and now we can handle these things without a hitch. And it's only this level of paranoia and obsession that helps us provide the confidence that it takes to ship this aggressively. And we've been shipping a lot. 2025 has been the year of IBRL on Solana. We've got a lot to talk about here. So let's start by talking about the major resource bottlenecks. We have about 4x headroom on compute side, so plenty of excess there. Similar story on disk for the typical case. We've got a lot of excess capacity there. Memory, this has really been the story of this year. We've cleaned up so many things when it comes to memory, so we've created headroom there as well. And on the network side, we've got a lot of validators running 10 gig or 25 gig NICs, and so we've got lots of headroom there as well, assuming we load the dang thing properly. And we were able to translate this into 25% throughput improvements on Solana mainnet this year. And even if we're not always filling the blocks, having that burst capacity is super important, right? You get an economic activity like as simple as a market open, the blocks are full. It's really nice not to leak that economic activity. And as I'm sure most of you know, throughput is governed by block limits. So we raised the overall limit from 48 million to 60 million CUs this year. And we tend to meter on these compute unit things. So every BPF instruction, serializing data, precompiles, all this stuff gets translated into CUs. We also linearize account data loading into CUs for reasons. I could rant on this stuff for a while, but I think the bottom line is we want to constrain things so that we can keep slots coming out every 400 milliseconds. So why haven't we activated the 100 million CU increase yet? Well, the key feature enabling this is creating a kernel bypass for the network layer. And it's funny because we often talk about network being the bottleneck for blockchains or like the Solana blockchain, but it's kind of not true actually at the moment when it comes to Solana. I wish it was true, but we're actually not saturating the NICs most of the time. But we do often max out on slamming the send M message syscall, allocating memory in the kernel, and context switching. And XDP bypasses this by allowing us to interact with the NIC from user space and increase throughput of this performance bottleneck by 200x. And this chart shows that latency difference between the legacy Agave code in blue and the new and improved zero copy XDP code, the purple line down at the bottom. And notice that we had to make the y-axis log scale so it would even show up. This thing is crazy fast. And call your validator today. This is in 3.0. Tell them to turn it on, right? We need critical adoption, and we'll get those 100 million CUs. There's another important block space limit that we've increased, and that's we've doubled the amount of throughput to the hottest accounts. And these are often the most popular assets, or it might just be the pump fun global volume accumulator. I don't know, but I digress. And this chart shows when we doubled that limit from 12 to 24 million and how users immediately gobbled it up. In addition to increasing the block capacity, we've also increased the ingestion TPS, oftentimes sustaining 100K TPS on mainnet. And this is essentially a measure of how efficiently we can move bidders into the auction house, which is really essential for building efficient markets, because to have an efficient market, the highest bid needs to win. For it to win, you have to actually look at all the bids. Right? And this used to give us a lot of problems because allocating all the memory for all these packets caused a lot of churn and a lot of issues. But we've been able to overcome a lot of that. But this is the historical reason for why we used to use stake connections, stake-weighted QoS for managing this. So we had something else as kind of a heuristic for quality transaction flow. And speaking of connections and ingest, we're making some changes to the default limits. So we are increasing the overall ingestion constants to 1 million packets per second. We're increasing the number of unstaked connections from 500 to 4,000. And we're unthrottling the per connection packet limits when global congestion is low. So lots of good fun things coming to get more transactions in. And finally, Alpenglow is coming. And Alpenglow, of course, is the new consensus engine that we're dropping in to replace Tower. It reduces transaction finality times down to 150 milliseconds, comes with increased safety, and enables us to have some much more intelligent ways of defeating the slot laggers. We first announced Alpenglow in the middle of this year, but we've made a bunch of progress. So we've been running a 50-node globally distributed test cluster under load for the last more than 4 months. And we've had so few problems, I fail to believe it sometimes. I had to get in there and make sure it's actually running stuff. But the team's really been cooking on this one, doing amazing stuff. And we're working to get this feature complete and rolled out on testnet early next year. And this also sets the foundation for a bunch more interesting stuff, such as better market structure. So Solana showed everyone that blockchains can be fast and affordable, and now we're going to show them that they can be fair and highly efficient while remaining trustless. So how are we going to do it? It's multiple concurrent proposers, or MCP. We're ending the single builder monopoly. Users and dApps want optionality in regional network latencies, traders want to have censorship resistance, and MCP is going to deliver all these things. And there's no middleman here. This is all the validator just playing different roles, right? So just keeping that pipeline flowing from the client. And we're already incrementally building towards this vision. We'll start shipping features to move closer to this ideal state with each release in the coming future. And by the way, I've been collecting the receipts of everyone doubting us, saying that MCP is going to take 2 years. Spite-driven development is the most amazing thing ever. Thank you for fueling us. All right, the last thing we'll talk about is DevX and OpEx. So we've heard the cries from the community. The rent is too damn high, and the transactions are too damn small. And so we're going to fix this. We are lowering the cost of state on the blockchain to make it more affordable for projects to bootstrap. Lots of users, lots of accounts, all that good stuff. I believe the state bond is somewhere around $1 million per gigabyte on mainnet, which, I mean, you get a lot of replication on Solana, but still, like, NVMEs are, what, 10 cents a gig? So this is a little crazy. We're going to do better here. And we're also increasing the transaction size up to 4 KB. So this is going to allow us to touch more accounts without using ALTs, and be able to craft more complex atomic operations in protocol. On the operational side, we're going to stop wearing out your disks so fast. We're making restarts faster, and we're going to do this by slowing down the incremental snapshot frequency, using win code instead of bin code for faster SerDes, and being smarter with what we actually write to disk. Yeah, shout out win code. Yeah, thank you. All right, and finally, SIMD 123 is going to ship, and so we're going to make it simpler for validators to share revenue from different sources with stakers and infra providers in protocol. Delegated stake directly increases the number of blocks you get. Those blocks can be valuable. We're bringing a lot of trading activity to Solana, and so it's important that we have a fair way of sharing those profits with stakers. All right. That was a whirlwind look at all the exciting protocol changes that are coming to Solana. Thanks for listening. You should now be properly amped up for all this cool stuff that we're going to ship next year. At Onza, we don't do roadmaps. We do releases. Follow me on X to stay up on all things Agave. Tune into the Onza blogs. And as always, the real alpha exists in plain sight on GitHub. All right. Thanks, everyone.
All right. Thanks, Brennan. The next on the Onza block, we got Alessandro De Sina. Come on in.
All right. Just in case anyone is wondering what it's like working with Trent, I recently discovered I have anxiety to ship. We were having a conversation on Slack where I was profiling Agave 3.0. And I saw a slowdown, which we fixed. And so I was making sure that we backported the fix to 3.1. And yeah, this is what I get from Trent, to which I'm like, you're welcome, Trent. So today I do want to talk to you about some of the things that I am very anxious to ship and that we're shipping soon, starting from XDP, which is actually in 3.0. We've been telling you, we've been asking you to test, because this is the one thing that will allow us to increase block space. I don't know if you remember, but at Accelerate, I showed you some performance profiles of XDP while we were doing some load testing. In the meantime, we've been doing some actual testing on both testnet and mainnet. And we measured that a turbine with XDP is as far as 200x faster than the legacy turbine with sockets, which is amazing. And you've also been helping us in testing different drivers and hardware, and we found some bugs, and we have fixed those bugs. So this was me sending a patch to the Linux kernel, fixing a bug in the Intel driver, and I have a patch coming for the Broadcom driver as well. I am mentioning this because we are literally the only team across all of blockchains sending patches to the Linux kernel, right? Probably something. The AFXDP that we created for Agave is not only usable within Agave, but it's a standalone, reusable, general-purpose crate for Rust. And so it can be used by any projects, and Harsh from Tiny Dancer has been contributing the receive side of the code. My initial implementation only included the transmit side, which is what we use in Turbine. I've been helping him with some performance tweaks, but he's been doing an amazing job, and now we're planning on integrating this code in TPU in Q1 next year, so we will also start ingesting transactions using XDP soon. Also, the guys over at the Overclock Validator, one of my favorite validators, so please go stick with them. They just released Shredcaster, which is a Jito Shredstream-like crate project that can be used to stream shreds outside of Turbine, but because it uses XDP, it has much lower overhead and sends with a much lower latency. So if you're using Jito Shredstream, consider also checking out Shredcaster, which uses Agave XDP. Another huge thing that we just very recently released is Wing code. As you may know, Wing code is the serialization format used by Solana, both in protocol, regrettably, and by on-chain applications. Bing code, as far as the bitwire format goes, is pretty good. It's not too bad, but the implementation is extremely slow. This has been a long-standing issue in Agave, because often we found bottlenecks in Bing code-related code, and we had to fix them, and this happened like dozens of times. Until a couple of months ago, when Zach, tired of fixing the same bug over and over in different spots in the code base, created Wing code. Wing code went from not existing to being the second fastest Rust serialization library in the first release. Obviously, when we saw that, we all went to Zach and we told him that we were extremely disappointed that it was second fastest. So the second Wing code release is the fastest Rust serialization library available today. Also at Accelerate, you might remember I showed many profiles, including a profile of Agave crossing the epoch boundary. At the time, I don't remember exactly what release we were running on mainnet, but it used to take more than 2 seconds to cross the epoch boundary due to some computations that we have to do right at the boundary. I told you that we were starting to look into them, and yeah, we've been looking into them. Now in master, we can cross the boundary in less than 400 milliseconds. We are very close to not skipping slots anymore. We still sometimes do skip one slot, but Michal is working on a fix so that we will never skip blocks again. Shout out to Horan and Michal for the amazing work that they've been doing here. This is probably the most exciting change that is coming to replay in Agave. This is 10 seconds worth of profiling Agave while doing replay of mainnet transactions, actual mainnet load. If you see the red lines, the red markers in the profile, each one of them is a disk operation, right? In these seconds alone, there's over 1,100 disk operations, right? That is bad because every time you hit the disk, you need to wait for the I/O request to complete, so that adds jitter to both banking and replay. And also, it's bad for the lifetime of your disk, right? The more we write, the sooner your disk wears out. This is the same profile with the code in master, and I actually believe that we backported most of the fixes to 3.1. You can barely see the markers. In these 10 seconds, there's less than 80 I/O operations. So great work, I/O people. And it's actually pretty funny that the accounts database is probably the component that has improved the most in the last year. Because when I first started this performance push almost 2 years ago, whenever I tweaked something in Agave and I wanted to recompile and restart the validator to see whether my fix was effective, I would have to wait more than half an hour to restart. And I would go to Brooks and complain, like, why does it take so long to restart a piece of software? It's like mental, right? And the answer used to be, why are you so obsessed with restarts? Maybe just don't restart. And I was like, but this is where we are today. It used to take more than 30 minutes to restart 1.x. 2.x restarted in less than 10 minutes. 3.1 will restart in less than a minute, and 4.x will restart in less than 30 seconds. And this is only with the changes we've done to the accounts DB. It does not include some changes that we're planning to do to replay and repair. So we will start even faster. And finally, at Accelerate, towards the end, I showed you some bugs in the scheduler, including this one, where the scheduler is actually busier doing some overhead synchronizing with POH instead of actually executing transactions. So in this specific profile, we're spending 61% of the time, the banking time, so while Agave is a leader, just doing this overhead, not actually scheduling transactions. And this is 3.1 instead. We have completely fixed the bug, and the workers are busy. They're processing transactions for 91% of the time, and the remaining 10%, you just need to send more transactions, okay? This is how that conversation ended with a trend. I love 3.0. It's the fastest release we've ever done. 3.1 is so much better, and I can't wait to release it. Thank you.
All right. There we go. The next up is Max Resner. Please give it up for Max.
Hi, everyone. This is the MCP final V2 final this time, for real. We've been talking all year about MCP. I want to talk about the first steps to getting it into production. But first, let me tell you why we've been talking about it all year. Solana is fundamentally for trading and about trading, and it has been from day one. That's why we started off with Serum. But now we're here. We have these new prop AMMs. And the question is, how do we accelerate that, make it better at the protocol layer? So let me talk you through some examples. Usually in finance, we have these kind of common value things that look like auctions. So here, the yellow, we don't know where those candles are going because that hasn't happened yet. But the green and red, those are candles that have already happened. So that's our setting here. And usually we'll have something like a prop AMM Oracle update that will happen at various times. And one thing that's interesting in our current structure is there's a single leader. And so everything goes through that leader. And so that leader gets to act slightly later because they can co-locate with their validator and they can insert things right at the end. But what happens when that leader decides they want to be the only person who's allowed to submit new information to the chain? In the current protocol, they actually can do that. And we actually are seeing some interesting stuff on mainnet where oracles are not getting in for various reasons because of late packing or because of other reasons. And so this has kind of transformed from not necessarily a theoretical attack to something that's going on right now on mainnet with late packing. So we want to guarantee with MCP that censorship resistance is impossible. So another thing that we're maybe interested in, and we're not going to talk about too much how to solve it today, but just so you understand where we're going, is because the leader gets to bid later, he gets to see a little bit more of the price data. And as an auction theorist, that makes the auction much less efficient. And the idea is that if the price goes up, like here, the price went up, he'll get outbid by the guy who bids later. If the price goes down, he's actually overbid. This causes what we call unraveling in financial markets, and it makes the market much less efficient. So what happens? How do we fix that? Well, if we could hide the Oracle update from the leader, and we had censorship resistance, you can do a mixed strategy if you're the player who acts earlier. And that mixed strategy will allow you to still play the game without that complete unraveling that we're worried about. And moreover, the less time advantage you get, the more we IBRL that difference between the leader and the Oracle updater who's not the leader, the less distortion there is in this mixed strategy model. So that gives us two properties that we can formally define that we're trying to achieve. And today I'll be talking about how to achieve selective censorship resistance. It's very simple. When you submit a transaction to the chain, either you should get in or nobody should get in. That's fairness. Another property that we might want, and it's related to the mixed strategy that I talked about, is hiding. And there's two definitions up here. One of them is valency, which is, you can sort of think of like finality, but before any node knows it's final. Just means the last slot, such that no matter what happens from that point onwards, the things in the log are going to get confirmed. And that allows us to define a hiding property, which could also be called pre-trade privacy. Basically says that an adversary can't guess what's in an honest leader's block before the protocol becomes valent. So let's talk about how to actually achieve that. Stop talking about what and start talking about when and how. Here is an example of the modified flow that we would have going from Alpenglow to Supernova Part 1, which is the kind of minimal version of MCP that will get us to multiple leaders and censorship resistance. Every box on here, as Brennan said, he had a similar graphic, is a validator. They're just chosen to participate in different roles. And as you can see in Alpenglow, that's also the case. So we have clients sending transactions to a leader. That leader sends shreds to relays or turbine routes. And those get sent to validators who vote and participate in Alpenglow's voter consensus protocol. So the flow is actually quite similar in Supernova Part 1. The client sends transactions to proposers. Now there are multiple of them, as we hoped. We ended the leader monopoly. Those proposers each send shreds to the relays or turbine routes. And then those relays immediately forward those shreds to the validators as they do today in the retransmit stage. Hopefully, if you're running Agave, you're using zero copy, so that happens faster. But another thing is happening. The relays are sending one more message, which is an attestation, to the leader. And the leader is aggregating those attestation messages, and that's the block that we actually come to consensus on. And I'll talk in a little bit in more detail. That'll be the most technical part of my talk, is how does that happen. So just as a recap of Turbine, we use this core technology called erasure coding, which is super sick, and it's one of the coolest parts of Solana. It lets us drop some packets and not be too worried about message delivery. And the structure kind of looks like this. You shred the block into erasure-coded packets, you send it to the relays or turbine routes, and they broadcast it on to everybody else. We're keeping that same structure here, only we have multiple proposers. They each create a block of transactions, shred those blocks into erasure-coded packets, and send them to the turbine routes or relays. Then those relays will immediately broadcast them onto the validators as they do today. But another thing they will do is they will send messages to the consensus leader about which shreds they've received. They will send signed I have messages, and we call those relay attestations. They're attesting to which shreds they've received. Now the consensus leader, let me just go a little bit into what that is. Basically, it's just a mapping, just a dictionary between what proposer 1 sent in the root of their shred. So all it is proposer 1 sent this block. That's just the digest of the block or the block ID. So once you have sent all of those to the consensus leader, it's the consensus leader's job to pack an aggregate block, which has an aggregation of the attestations. That's what actually gets sent out. What does that look like? Well, it's just a matrix aggregating those attestations in the structure that you see here. So once they send that out, validator's job is to vote in Alpenglow, in voter, but we have a slightly different voter validation protocol here. So first of all, the aggregation must include an attestation from at least 60% of the relays. Second, if any block has 40% of shreds present in the aggregation that are valid, then that block is scheduled to be included. If it has less than 40%, it won't be included. And then if we have 20% shreds, that means that we can reconstruct the block. And all validators reconstruct the block locally and make sure it reconstructs before voting. And they can do that without a delay because they should have received the shreds already. Now, what do we do with all these proposals? We take them, we order them by priority fee and dedupe them, and then we execute them in order with some additional fee payer checks to prevent DOS. So that's basically the whole protocol. And what we tried to do with this is basically give the minimal thing that gets us to censorship resistance as fast as possible, but is also safe and live. And as I said, we've been through so many of these designs. So on the top, you can see Alpenglow here, and it's great. It's provably bandwidth and latency optimal, but it doesn't have censorship resistance, which is what we're trying to achieve. A couple of years ago, we proposed a protocol called Multiplicity that worked with Tendermint. The key issue there was that the proposer, the leader still had too much power to censor proposals, so we didn't achieve that full censorship resistance property that we had. Braid was a proposal where each thread was a separate consensus algorithm. The issue with that is the intricacy of consensus means that each consensus thread can sometimes hang, and so you go at the pace of the slowest chain. That's that log k factor there, which can sometimes be pretty bad. Then we had this other thing that I think maybe totally suggested at some point, which was, what if we just send all the blocks on Turbine and then we vote on the aggregate of them? The issue with that is it multiplies the failure rate from Byzantine nodes by a factor of the number of proposers. In Chicago, at Core Dev Day, I presented this protocol called GNR, and it was kind of almost what we see here. The issue was there was a kind of slight liveness issue, and then there were some latency and bandwidth issues. We fixed them in Supernova Part 1, and so that's what we want to bring. As Brennan said, we're collecting the receipts of everybody who says we're not going to be able to ship this thing quickly, and I will be posting them on Twitter. So you have 5 minutes to delete. I'm going to go backstage and save the folder, okay? Thank you, guys.
All right, thanks, Max. The next one from the Anza block, we got Alexander Meissner. Alexander, come on up.
Cool, nice to see you. So today I'm going to talk about all the things you need to know for the next roughly half a year that we're going to change. Because we at the SVM team, we develop, as the name implies, the SVM. So what we try to do is improve mostly bandwidth and performance in terms of throughput. There's not so much we can do in terms of latency, unfortunately. We try to reduce protocol complexity, which helps mostly other validator implementations like FireDancer catching up. And also it reduces attack surfaces and therefore improves stability and robustness. And finally, a point which we have been ignoring a bit too much in the past, which we're trying to do better now, is improving usability for you guys. All right, but unfortunately, all medicine has side effects, and there are things we need to do, and specifically also you need to do, so that we can unlock the performance gains and the robustness gains we want to have on our chain. Specifically, we are going to introduce, mandatory for all programs, even the deployed ones, a few new restrictions. All of these should not be done in sane programs, but for some historic reasons, they are, for example, part of the SDK or have been. So please test your programs with a recent, or hopefully most recent test validator and all feature gates enabled. And some of you will see these 3 error messages. And the fixes for them are pretty simple, but they need to be fixed. Specifically, I want to call out programs here. And if you find yourself in there, that means that your program is not going to break entirely, but some of the instructions will fail. So please take a look and run the latest test validators. So, but again, there's an upside to all of this. What we're planning next after that is so-called API v2, which will allow us to expose most of the transaction information all the time, basically for free. That includes the signers and all the pub keys in a transaction. We will change that you will have to do account metadata changes through syscalls. That means you have to kind of adjust some parts of your program. In turn, you gain basically unrestricted resizing of accounts, no more limits in terms of 10 kilobytes. You get a lot cheaper entry points, you get a lot cheaper CPI, and a lot simpler CPI. So we're getting rid of account info. And we're also getting rid of the pub key and the account meta, which we will replace by an index. So furthermore, we're going to introduce SBPF v3, which for you guys mostly just means you have to recompile your program with the latest toolchain once. And that should be it. There should be no changes to the actual source code. And hopefully then your programs will simply become much smaller. And furthermore, it will also allow you to use more different toolchains because we're much closer to other eBPF toolings, especially the upstream LLVM. So then we have further protocol complexity reductions. Specifically, the loader is going to change. There will be an overhaul of the upgradable loader. That means both inside how the account layout works, we have to do that to unlock some performance gains in the validator, and also to what specific actions you can do in the upgradable loader. The entire thing is codenamed loader v4. If there will be an actual change to the owner, we don't know yet. The thing will be opt-in in the beginning and then become mandatory later. Specifically, I think what a lot of you are looking forward here is after that, you will be able to completely close and reclaim program accounts, including the address and including all funds, like entirely deleting the account. And existing workflows like the buffered redeployment will continue to function. All right. Further improvements we want to do for you guys. There has been a lot on quite a rise in increase in interest for debugging specifically, and also for code coverage tooling. So we have been working with our partners and trying to improve the situation there. And I think we're close to enabling debuggers to even go through CPI throughout an entire transaction stack. Furthermore, there have been some smaller changes. For example, there is this issue that you have to pass all the instruction accounts before you get to the instruction data. We now also pass in the instruction data pointer as one of the arguments. So you will be able to first discriminate your instruction and then pass your instruction accounts or skip them entirely. And now the most interesting part probably is we will be able to raise the limits of the CPI nesting depth from 4 to 8. And we will be able to raise the number of instruction accounts in CPI from 64 to 255, which means you can CPI all accounts simultaneously of the entire transaction at once. All right. Finally, a few things which we are looking forward to in the future is we're still on the mission trying to basically migrate all the built-in programs we have to core programs being deployed on-chain in BPF itself. And specifically, that includes, like I mentioned, the loader, that also covers the vote program and the proof program. And we have been looking into potentially exploring different ISAs or more compiler options and a few more complex performance optimizations, which probably are not too interesting for you guys. But if all of you have anything that has always been on your mind, like this is the feature I need in the SVM, and I've been dreaming of this all my life, essentially, then please come to us, meet us on Discord or on the Cindy discussion groups, or simply after the talk. You will see me because I'm wearing red. All right. Thank you, guys.
On time, and we got some time left. All right, so the next one is going to be an interesting one. It's the team from Anchor. Robert and Jacob, come on up.
All right. How's everyone doing? All right, so we are here to talk about Anchor, where Anchor is today and where we kind of see Anchor going in the future.
From
so for
Anchor,
those who do
Robert
not know
and
me,
Jacob.
my name is Jacob Creech. I do developer relations at Solana Foundation.
My name is Robert, and I'm the CEO and auditor at OtterSec.
Yes, so as developer relations, one of the things that I really care about with Anchor and with Solana in general is I want to make sure that we have the absolute best developer experience, tooling, and also the most optimal way of building Solana smart contracts or programs today. And so that's a lot of what I want to see on Anchor, and we have a lot of work to do, but we'll talk about that a little bit today.
So I said this at MEVCamp, actually, but one thing that we really hate as auditors is framework proliferation. And in the past 1 or 2 years, one thing that we saw was every protocol, or not every protocol, but a lot of protocols designing their own frameworks. I think we saw 2 or 3 custom frameworks launch in the past 2 years. One thing that we're really excited to do when working on Anchor is to take all of those learnings from these separate frameworks and bring them into Anchor. Having different frameworks increases the complexity, not just for developers, but also for auditors. It takes a lot of time to learn the nuances of each different framework and also to understand where it can go wrong. If you have 2 or 3 different frameworks, you need to learn each one individually. And one reason we're so excited to work with Jacob here from Foundation on Anchor is because we can consolidate everything and make Anchor, the one framework to rule them all.
Yes, and with that, we are excited to announce that if you can go out and try an Anchor 1.0 release candidate right now. It is actually released. Don't check the release time. It'll be very fun.
It was like 20 minutes ago.
Yes. But we're going to talk a little bit about what goes into the 1.0 release. Please try it out. Give us some feedback before we can actually make it a full 1.0 release. It's part of a release candidate, right? But the idea for Anchor 1.0 is that it is a step in the direction of what we just said, right? It is a stable version. I know a lot of people have had issues with Anchor in the past. It's a stable version that you can rely on to build Solana programs for now and for the foreseeable future. So let's go into some of the changes that we can see on it. Go for it.
Okay, so if you're a developer, maybe you don't care that much about this. But if you're an auditor, hopefully you're super excited. One of the things that has been super annoying in Solana development in general, but also in Anchor, is duplicate accounts, and specifically duplicate mutable accounts. This is a super common foot gun in Solana, where you can pass the same account multiple times. And in Anchor, what this does is only the last account persists. And the reason for this is a little technical, but essentially the Anchor exit handler will serialize each account in order. But because it's doing these sequential serializations, only the last version of that duplicate account gets serialized back. Which means, for example, if you have like a token account, you're transferring tokens, only the the second version of that token account gets persisted back into memory. And this is a huge problem because a lot of Anchor developers don't know about this. And it's a very common foot gun that we see as auditors that we have to manually point out and remind developers. And it's been the cause of quite a few critical issues that we've seen. So in Anchor 1.0, this will no longer be a thing. You can always opt into duplicate mutable accounts, but by default, the framework will handle this edge case for you. It will prevent you from passing in two accounts of the same pub key into two separate Anchor accounts.
Yes, and as part of making Anchor stable, we're also going to be upgrading Borsch. So Borsch is currently in the current version of Anchor of 0.32.1. It's kind of like on a 3-year-old version of Anchor at this point, and it actually can't work today with Solana SDK 3.0 or higher. So we actually had to upgrade it to a V1. So this will not only allow us to make sure that we are stable from now into the future, but it will also make sure that we don't have all these weird dependency conflicts just suddenly in a 1.0 because no one wants that kind of issue. And on dependency conflicts, one of the things that we wanted to also talk about with Anchor V1 is that Anchor, part of V1 is it's not just a framework anymore, but it's also a tool chain in itself. We have a bunch of different tools within the ecosystem that people use today. We have Surfpool, right? A lot of people, if you're not using Surfpool, go use it. It's awesome. But Surfpool is an awesome little Solana test validator, which is a direct upgrade from the current Solana test validator. We have a lot of people using LightSVM or Mollusk or a bunch of other tools in the ecosystem. A lot of people use verifiable builds. What we did this time around is we packaged all those tools all under Anchor as the tool chain. And not only can you use Anchor to build Anchor framework programs, but you can also use Anchor with all these tools with your native programs, your Pinocchio, whatever, and it should build and work just fine. What's also great about this is in Anchor 1.0, everybody kind of talks about like, oh, I ran into dependency issue with this library or dependency issue with that library. What we kind of did with this is instead of having this mix and matching of a Solana CLI version, a platform tools version, an Anchor version, you would just have to know the Anchor version. Because in Anchor 1.0, we removed the requirement of the Solana CLI, and we also have the platform tools version tied to the Anchor version as well. So you don't have to worry about that. It will just work whenever you build. That's part of being stable in Anchor today.
Yeah, I mean, that was super cool. I mean, I feel like we can't overstate how amazing this is. I mean, there's been countless times where we're trying to audit a program, and I'm like, how do I compile this thing? Because of all the different versions of tools that you need. And yeah, we're going to talk a bit more about the tool chain later, but this is, I think, a super great addition to Anchor.
So as part of getting to an Anchor 1.0, we did a lot of work since we took it over this year to actually get it into a maintained state. So we did, as you can see from this graph, you can basically see when both Robin and I started working on it, especially on the issues closed part. Thank you also Henry, if he's in the crowd here, for helping us out. He helped us a ton as well. But we wanted to make it into a maintained state so that if people are making new contributions or they want to make an issue or they want to contribute back, they can. It's a lot easier. So we have under 100 PRs open now.
Yeah, we got under 100 PRs finally.
Yeah,
it's like 300 for the longest time.
Yeah, it was a big cleanup. We moved a bunch of things in that have been sitting forever. But we really, if you are in the crowd and you had problems contributing back to Anchor, please open an issue. We can talk it out. We are here to maintain it and make it better.
Another thing that we've been doing is trying to involve the community more. I think a big part of what makes Anchor successful is the fact that everyone uses it, and we want to be mindful of the impact it has on everyone's development cycle. If you have thoughts or feedback or ideas for where you want Anchor 1.0 or 2.0 to be, you should join our community calls. We host them once a month. We skipped it for this month because we're at Breakpoint, but next month will be on January 14th, and we host it around that time every month. And both Jacob and I and other people from the team are there, and we want, again, to hear your feedback, to hear what you have to say, to understand your pain points so we know what we should be doing to make it better. And I think as Jacob said, we are really putting in a lot more effort to maintain this thing, and we want to engage the community and understand how we can make this the best version of the framework it can be. Sort of on that note, a lot of people don't know this, but Anchor actually has been audited. We audited some of the previous versions, and we're auditing the 1.0 release. If you want, you can go to the URL on screen to see the audits. And we're also working on the security lifecycle for Anchor as a whole. So we launched a bug bounty program where you can email your issues or ideas. Actually, they go directly to Jacob and I. So we will see the issues if you have any, and I actually check my email and respond to them relatively quickly. So I think the point here is that if you have concerns or ideas or anything that you see on Anchor, we're here to look at them and here to help. And we really want to make Anchor the best it can be.
On that note, we wanted to also talk about, so we talked about Anchor of where it is today, right? We wanted to talk about where we want Anchor to go in the future. So there's a whole bunch of things that we talked about at the beginning of hey, we want to make sure it's the best developer experience. It is able to do all the things that these different frameworks are doing, or that are being built today are doing already. It can have good defaults. It can have, it's optimized but easy to move to something low level like Pinocchio, rather than there were some times or some teams in the ecosystem that spent 8+ months moving their programs from Anchor or native to Pinocchio to get the extra juice out of their program on chain. And so we want to make that easy. So as part of that, the first thing that we want to do is we want to switch out the internals of Solana program with Pinocchio. You may have seen me talk about this every once in a while on socials, but that is really important to us because one, it gets us almost no dependencies, but two, it also makes it very easy to optimize. And then we're going to also make, instead of Borscht and a bunch of the other work that goes in today, we're going to make zero copy of first class citizen within Anchor v2 so that you don't have to worry so much whenever you're doing the loading of accounts or the writing of accounts, that sort of thing. So that is a big effort that's going on right now so that we can get this v2 out the door and make sure that, hey, if you want to use Pinocchio, you have both the optimization that Pinocchio provides, but also the best developer experience that you know and love from Anchor.
One important theme for us around Anchor v2 is also making it extensible. We want this to be the framework that all developers can use regardless of your skill level. And that we have worked with developers who have built their initial programs on Anchor. They realized they wanted to get more control over the framework, and then they couldn't get that with Anchor. So one of the things that we're adding along this theme is a better trait-based system, where if you're a developer, you can override parts of Anchor to get exactly the functionality you want. So for example, if you don't want to use the default entry point and you don't want to use the default account parsing, you can now override that in Anchor v2. If you really want to optimize, for example, if you're a prop AMM and you really want to optimize your Oracle updates, you should be able to do that in Anchor v2, where you only have to opt into the parts that you actually want to. And the goal here is, and the hope here is that regardless of your level as a developer, you can use Anchor, and it can be the framework that you stick with. Another thing that we're really excited to announce is Anchor Fuzz. So we want to bring native fuzz testing to the Anchor framework. Fuzzing is an immensely useful tool, and we think every developer should be able to access it and write it, similar to how you might write a unit test. So as part of this, we're adding this is a screenshot from the test instance we have, but we're adding a suite of CLI tools where you can create a harness, you can run the harness, you can check the coverage, you can check your crashes, and you can see, sort of get all the features you expect of a normal fuzzing tool. We don't have that much time today here, but if you're interested in learning more, we're actually going to, or someone from the team is going to be giving a talk at the Dev Cave tomorrow. I don't know exactly what time, but he'll be there. Also, the Dev Cave is a little hard to find, so if you don't know where that is, it's like you go into Breakpoint and then you take a hard left, and it's on floor 1.5. So not floor 2, it's like 1.5, and it's like kind of stuck in the corner somewhere. We're also hosting a CTF there, so if you want to compete and you want to win some prizes, I think that the top prize is 30 Sol, which is like $4,000. But yeah, if you want to compete and win some prizes, definitely encourage you to go there and check it out.
So also on Anchor Fuzz, it's part of, if you remember, I'm talking about making Anchor also a tool chain that you can use to build programs. This is just going to be put in. So this is not specific to 2.0. We'll also add it to a 1.0 eventually when it gets built and fully released. So you'll have like a 1.1 or 1.2 or something at that point. It's just building the best tool set for you as a developer to build your programs.
Yeah, one thing we need to figure out is the disambiguation of the naming, right? Because there's Anchor the framework, and then now we have Anchor the tool chain. But that's a tomorrow problem. Another thing that we're excited to talk about is linting. So this is similar to the fuzzing, where we want to bring more. We want to increase the water level of security in the Solana ecosystem, and adding more features to the Anchor toolchain is one of the best ways to do that. So we're also excited to announce Anchor linting, which is a DY-lint-based linting framework. Essentially, it's static analysis. So we have hard-coded some rules for Anchor programs. There's, for example, maybe you want to check for reloading an account after a CPI, which is a pretty common footgun that a lot of new developers miss. We want to write these rules and then enable everyone to run them as part of their product lifecycle. So before you submit your code to an audit, you should be able to run Anchor lint, pull down the latest rules, see how it looks, and fix them before you even submit it to an audit. Another thing that we want to do with this is to make it open to everyone. So you don't have to use our rules. Anyone in the community can contribute rules and add rules either to our repository or even self-hosted. And Anchor lint will give you ways to pull down these community rules and run them on your project. So if you have ideas for interesting bugs that you think we should be looking for, you can post your own rules, and everyone in the community can use them.
Cool. So thank you for coming to learn about Anchor. If you have any questions, feel free to message us on Discord. You can see our two usernames right there. Or join the Discord for Anchor. Join the Anchor contributors channel and start messaging us. We're happy to have a chat on any new features or any problems that you might have building with Anchor, especially as we build towards V2. But thank you, everyone.
Robert and Jacob. So now it's my pleasure to welcome Francisco Piccoli, the co-founder and CEO of Almanex. Come on up.
Hi, everyone. I'm Francesco, co-founder and CEO of Almanex. At Almanex, we're building an AI security engineer that can help teams building on Solana ship code without bugs and catch any bugs before bad actors do. We're soon going to have trillions of dollars moving on chain, from life savings, real world assets, and institutions building products on Solana. Blockchains are becoming critical infrastructure. Solana is becoming critical infrastructure, and projects on Solana and protocols on Solana are critical infrastructure. And so we need the best defensive tools we can build to prevent bad actors from exploiting this critical infrastructure. So we're soon going to have superhuman capabilities in many different fields. And at Almanex, we're building superhuman capabilities for security. We are a team of AI and security researchers based in New York. At my previous company, I investigated some of the largest hacks and exploits that ever happened in crypto. And I grew frustrated because a lot of teams were not taking security seriously, or they were shipping bugs that were well-known, and companies that the folks before me can help catch. Unfortunately, audits are very expensive as well, right? And so having a tool that runs continuously during your PR process is something that we thought was needed, and ideally having an auditor available 24/7, available via API. My co-founder was at Coinbase, and we built a team of folks coming from all across the industry. There's a few trends that have been worrying me quite a bit recently, and vibe coding is one of these. We entered this age of vibe coding where literally teams are shipping millions of lines of code a day. We have companies like Coinbase and Google that are generating 40–50% of their code, accepted code, via AI. Cursor alone, this was like a statistic from April, they're pushing, their users are actually like pushing 1 billion lines of accepted code a day. Those numbers are only going to grow from here. And so these, unfortunately, like produces like massive bottlenecks, right? Because if we're moving towards a stage where teams are shipping like entire vibe-coded apps, and I was just talking to the co-founder of another security company backstage, and they're seeing programs and smart contracts also being vibe-coded. Like, who is checking that there's no bugs, or there's no malicious code that is being injected, or simply buggy code that is making it to production? Today, like security and engineering teams are literally swamped with like alerts from static analysis tools. Like they do some fortunately, they often do like audits. They run bug bounties. Like they have other tools, but like the massive amount of alerts that they get makes it very hard for them to go and like then triage and then pass it to the engineering team to go and actually patch these issues. And so often, especially in large organizations, like we see that what actually gets patched is not the entirety of what gets caught, right? Because there's a lot of noise. And so you guys, how many of you guys have seen the recent Anthropic report that were released around security? Quite a few, right? And it's funny because like they released two recently. Like the first one that they released talks about like cyber espionage, and like it's a large-scale cyber attacks that they took down from like Chinese state-sponsored hacker, where these like bad actors were using AI in their exploit. And then like a week or 2 weeks after, they released another report where they used AI to like exploit smart contracts deployed on chain. And it's getting kind of scary, right? Like these models are getting to abilities of like very thoughtful and very senior like security engineers. We're not there yet, right? We're like at this moment we're probably at the level of like junior security engineer, but if the trend continues, we're soon going to be at superhuman ability when it comes to security as well. And there's some hints around the Balancer hack, 120 million like lost recently, where like the attackers might have used like, AI in their exploits. And so that's kind of like the main reason why we started Almanax. We wanted to build like the best AI tools from a defensive perspective to teams that are building on chain. And so Almanax is an AI security engineer that scales with your code base, continuously reviews code, investigates and triages alerts, and help actually patch alerts and security issues at scale. I was supposed to do a demo, but like I'll do a few slides so I have the clicker. We built a system that kind of like reasons through a code base, no matter its complexity, like a security engineer would, right? And so in order to do that, there's multiple things that you need to do, because like code bases are very large, context windows are small. And so you need to give these agents the ability to navigate the code base, right? And so when we start a scan, and when our customers start a scan, whether they're running on their full repo or they're running their CI/CD pipelines or PR review process, we create like a threat model of the repo. We look at invariants. We create an abstract syntax tree. We create like a function call graph, so that the agents are able to navigate to different parts of the code base and understand like the logic of certain functions like a security engineer would. And so this runs 24/7 in the PR review process, but it can also like be used as a tool that runs like before an audit, for example. So we work with a lot of teams that are about to go and do an audit. We work with auditors as well. They're using these tools during like their review process. And then we also investigate existing like alerts and help like teams triage. If you're a large organization, you're probably running different security tools. And generally, what we've seen historically is that 90% of the alerts that teams get are false positives. And so you're drawn, like these teams are drowning in noise from like these alerts, and often they might like dismiss something that isn't really a false positive. And so what we developed is this system that kind of like does, with the context of the code base, does an automatic pass or triaging to help prioritize what to fix. And then the very last step is actually going and patching. And so if you have like hundreds of alerts or hundreds of vulnerabilities that are found, well, I hope it's not a program that you're about to launch on chain, because that would be very worrying. But if it's like a large like monorepo or a large code base, you want to be able to like patch at scale. And so back in the days, you would like the security team would pass all these alerts to the engineers. Now, like we can patch directly in line if an issue is like an easy one, or we create a draft PR. So we're working with like security teams today from like various protocols and like wallet infrastructure team, working with Privy, and we're working with a bunch of Solana programs, Solana protocols as well. And today, I want to announce our collaboration with the Solana Foundation. We worked very hard to build an agent that is good at understanding Solana protocols. It's good at understanding Solana programs. It has context on like Anchor. It has context on anything that matters when like building something on Solana. And as part of the collaboration, we're providing, and Solana Foundation is helping us like provide like 1 year of like free audits for projects that are building on Solana. And so this is the moment where you guys clap. I was like, this is cool. This is amazing. And with this one, I'll pause. You can get in touch. You can sign up. And if you want to see this directly on your code base, you don't even need to talk to me. This is my information. But you can go at app.almanax.ai, and you can run like an AI audit. And then we'll send you to some of the fantastic auditors that I see here in the space and in the audience, like runtime verification. But thank you, guys. I'm Francesco. I'll talk to you later.
Thank you, Francesco. All right, next we have Felix Wilhelm. He is the CTO co-founder of Asymmetric Research. Felix, come on up.
Hi everyone, thanks for having me. So my name is Felix. I'm the co-founder and CTO of Asymmetric Research. We are a Web3 security company, and we spend a lot of time securing Solana infrastructure, like validators or bridges, as well as like on-chain programs. And in this talk, I want to give want to highlight a couple of key takeaways about the state of Solana program security in 2025. So I think overall we are seeing the space maturing. So like the security of on-chain programs is improving, but we are also seeing some movement in the other direction. So I have a couple of like high-level things I want to call out, and then wrap it up with kind of a forward-looking statement, like how do we make sure we get this space into an even better shape. So the first thing I want to talk about is a bit like the onboarding story for new developers, right? So over the last 2 years, especially 2024, we have seen a lot of like new teams onboarding to Solana that develop new and complex on-chain projects. And on the one side, Solana is lucky that we have like the experienced developer teams who deeply understand the runtime. They know like the bug classes, they know the pitfalls, and they're able to write secure and highly complex code. But for like these new developer teams that maybe come from the EVM world, we see that they still struggle with insecure by default APIs and pitfalls. And I know there are quite a few auditors in the audience, right? And I think everyone has like these different type of bug classes that they're always looking for if they review code written by new teams, right? It's just stuff that's very hard to get right. We see basically the same mistakes repeated over the last 2, 3, even 4 years. My typical example is everything related to instruction introspection, right? Every time you look at like the instruction sysfile and try to reason about what happened in the transaction before or after you, that's really hard to get right, especially once you involve CPI. Related to that is like the extreme power and complexity of these SEC-P and ED 25519 native programs for signature verification, right? They're very easy to misuse, very easy to introduce critical bugs, and I think every developer who has worked with them know how hard it is to make them secure on first try. On the framework side, I mean, the one thing that Robert and Jacob are fortunately addressing is like the pitfalls around the duplicated mutable accounts, right? Due to like runtime behavior and framework internals, you basically just lose modifications as soon as you work with duplicated mutable accounts. And then if you step away from frameworks, you run into different issues like bump seed, canonicalization is something that I think a lot of developers struggle with when they're newly on board on Solana. And I think an interesting example that we can publicly talk about was a vulnerability we recently reported to the Relay Link team. So Relay Link is like a intent-based cross-chain bridge. And on the Solana side, the intent here was run this ED25519 instruction to verify signature, right? Use that to like protect withdrawal of funds. But the team didn't fully parse the instruction format out of the instruction stream. Instead, they would just take the sign-up hub key as well as the message hash out of hard-coded offsets. So these are like the yellow numbers you see when they access the instruction data. That's completely, or that's very broken. So you can relatively easy bypass that, get a full signature verification bypass, and steal all the funds in the protocol. I won't go through the full vulnerability and exploit, but you can check it out on our blog where we did a write-up when the bug was patched. Another topic that becomes more and more interesting as Solana becomes more mature and you actually have on-chain programs that are running on-chain for a long time, right? Is regression safety. So what we see normally is you have a core developer team that designs and develops the initial version of a product or a feature. Ideally, they go to audits, so they are confident in the security. The core developers know the code really well. They have a lot of insights about all the security critical invariants in the code base. The auditors have as well, right? Because they reviewed the whole thing. You launch into mainnet. Ideally, you survive, you don't get hacked. Maybe the project is actually super successful, and you keep running in mainnet. And then your developers might change jobs, they might retire, or they get promoted to management. And at some point, you want to introduce this small bug fix. You want to fix a weird issue that's not critical but kind of painful, or you want to add a small feature, right? And that becomes where it's really critical. At this point, the knowledge you have about the code base might be stale. The developers that really understand this thing might not be available. So maybe a new developer, a really smart person, is adding code to this, just committing a small commit. You might also have an audit on this specific change set. But at this point, probably the auditor are also not familiar with the whole code base, right? Because this thing is 2 years old. And then suddenly, that small change can actually break security invariants in other parts of the code base. And to make this a bit more realistic, one example I wanted to call out was a recent vulnerability we reported in MarginFi, right? So this is a very mature project, has been heavily audited over multiple years, has a lot of TVL. And this commit basically added a new transfer to new account instruction, which if you review it in isolation is pretty simple. It doesn't have complex logic in it, does all the signer checks correctly. Seems pretty harmless. It turns out that it doesn't integrate well with MarginFi's flash loan functionality. So what you could do is you take a flash loan, you invoke this transfer new account handler on the account that's taken the flash loan, and then you never pay it back, right? You never have to pay it back. Instead, you just walk away with the money. So this was a vulnerability that was introduced with a very simple change and could potentially lead to a loss of $160 million. So I think this shows that a lot of the stuff we have on-chain is really brittle, and it's really important to have defense in depth measures to make sure you don't introduce these bugs 2 years after your launch. The other thing I wanted to talk about is the rise of CU golfing, right? And as you probably all know, there's more and more interest in optimizing compute unit usage of Solana programs. So think of the stuff you see on Twitter or X, Pinocchio, P-token, Humidify, also Doppler for really efficient Oracle updates. And on one side, this is great, right? This shows we are getting more and more experienced developers. it's a sign of a maturing ecosystem that like people get comfortable enough with the runtime to actually do the stuff and invest resources in writing optimized and fast code. However, as like a security team, this also makes you really nervous, right? Like very often, heavy optimizations and security are kind of at odds with each other. A lot of the CU optimization stuff is basically removing safety belts that you normally have just from like the memory safe language that you're writing your contracts in. So with unsafe code and assembly, you're removing like these memory safety safety belts. Assembly makes the whole thing harder to review. Ownership checks is something like, if you really understand like the semantics of the SVM runtime well, you might think about removing some of these ownership checks because they are unnecessary. And obviously, a lot of the stuff you care about is like in the SDK, which is like heavily audited functionality. So we are seeing a lot of like rewrites and re-implementations of stuff that's not fast or not optimized, but where we are pretty confident that it's so battle hardened that it doesn't have like critical vulnerabilities. And the thing with these safety belts is that you don't need them if you don't write bugs, right? So like the argument could be, well, I just write perfect code and then like everything is great. But even if you look at like kind of the projects that are developed by like the best people in the space, so you see even the best developers don't always get it right. So the two examples are here are like pull requests from Pinocchio and ptoken, which are probably the highest quality code you can find in the space, right? Especially around like CU optimization. And the true pull request here is like one is a bug where it's like there's an integer underflow in an unsafe code block, which leads to an out-of-bound write in a logging functionality. The other one is in ptoken and was basically around a missing ownership check that could lead to loss of funds during the processing of batch instructions. So if even like these really experienced developers writing these like really interesting programs struggle with like the security aspects of it, I think the average DeFi project should be really careful before deciding to remove like these safety belts and drive fast, right? So keep that in mind when you want to fully jump on the CU golfing train. The final thing I want to call out is around Oracle risks, right? So I think, as you all know, like DeFi runs on top of oracles for pricing informations, and we do think that the risk of off-chain oracle compromises is not really well understood by a lot of projects in the space. So by the off-chain nature of oracles, you can oftentimes not really inspect where the price updates are coming from, how much you can trust them, and how easy or hard it is to compromise them for an attacker, right? So our suggestion here is that developer should spend much more time thinking about how a corrupted price feed can impact a protocol. And this is, I think, mostly an exercise in defense and depth, right? And again, like the safety belt mechanisms, where you can introduce features like price limits or like an emergency halt mechanism as kind of like these defense and depth mechanism to make sure that like a malicious oracle isn't able to, or like a malicious oracle price update isn't able to completely rock your protocol. A recent example that has seen like surprisingly little of public attention was a compromise of the Moonwell DeFi project, which is like an EVM-based DeFi project. They lost over $1 million because of a malfunction of an unsupported Chainlink Oracle price feed, which quoted highly inflated prices for a certain asset, which was then abused by an attacker. And while in this specific case, the like monetary damage might not be super high, right? Just $1 million. We are pretty confident that like we are going to see more and more of these kind of attacks or compromises in the future, especially when the on-chain attack surface gets more hardened, right? Because an attacker is always going to look for like the weakest spot. So if like your on-chain code is perfect, then maybe like your Oracle provider is actually the weakest spot in your security story. So what do we do about that? Like how can we help to get the space into a more secure place, right? And calling out, like Roberts and Jacobs talk about the new Anchor development, I think a great way to help improve the space is by building secure by default libraries and primitives. So Anchor trying to address some of the pitfalls in the framework around mutable accounts, but also introducing like helper functions to basically do secure signature verification in a very easy to or like very hard to misuse API. Will make it easier for people to onboard securely onto Solana. We're also investing heavily into improved tooling. I mean, the previous talk talked a little about AI agents, but also like tooling like static analysis, and the newly introduced Anchor fuzzing is hopefully going to help to make your projects more secure against like regression and user security vulnerabilities. And finally, we are also working on stress testing for Oracle compromises and misconfigurations. So ideally, developers should be able to kind of stress test an Oracle compromise against their mainnet deployment and see what actual damage this could trigger in their programs. Thank you so much for listening. If you want to read more about the issues I described, please take a look at our blog, where we always do like technical write-ups of vulnerabilities we discover. If you want to hear more about security in general, security on Solana, or fuzzing, please come to our dev cave. We have a Solana security CTF, where you can like play around with bugs like these. And tomorrow morning, we're also going to give talks about fuzzing on Anchor, as well as binary decompilation of like Solana on-chain contracts. So if this sounds interesting to you, make sure you step by the dev cave tomorrow. And yeah, that's everything. So thank you so much.
Thank you. Next, we have the co-founder of Neodyme, Sebastian Frisch. Sebastian, come on up.
So, welcome guys, welcome to this talk. I'm Sebastian, I'm the co-founder of Neodyme, a leading security firm here in the Solana ecosystem. And today we will talk about control, especially about who controls Solana's funds. There's this saying in more conspiracy-minded communities, follow the money. Today we are going to follow the seeds to find the money. So this was our starting question. As security researchers, we want to work efficiently. So if the top protocols by TVL are secure, most funds are secure. And indeed, we again got a Pareto coefficient here, or I don't know how you call it, this 80-20 stuff. Indeed, 80% of the funds in Solana are locked up in the top 7 programs. But how do we actually find out what are the richest protocols on Solana? Is it Camino? Is it Jupiter? Is it Drift? They all got a lot of value locked, or is it Squads? Take a minute, pause, and think about it yourself. Most of you would probably just go to some DeFi aggregator and check, but stay tuned. The data may not be that correct there. So how do we find it out trustless? To find this out, we have to understand on a technical level how smart contracts can control Solana funds. In Solana, we got the SBL token program, where all token accounts are stored. Those token accounts have a mint, USDC, Repsol, you name it, an amount, how much of that mint do we have, and most importantly, they also have an owner. This owner is a pub key, and then can be 3 types of pub keys. It could be a normal key pair, as you have it on your hardware wallet, on your hot wallet. It could be a seeded address. That's a bit of a lesser known feature. Think of it as PDAs for key pairs. Or it could be a PDA, a program-derived address. And if a token account is owned by such a PDA, it can control its funds. But what exactly are those PDAs? The goal was quite simple. We want smart contracts to sign for an address, so we can enable cross-program interactions, etc. And the problem is also quite obvious. The program cannot have a normal key pair, as I would do, because I would have to upload the key pair up to chain, and that kind of defeats the purpose of a private key. So the idea is we somehow allow smart contracts to pseudo-sign by deriving addresses from the program ID, which they then can invoke, and the runtime counts it as a signature. On a technical level, this is quite easy. We got two inputs. We got the seeds. This is just an array of bytes, so it can be quite everything, and the program ID, so the program that is signing now. And to find a program-derived address, we just take the hash of the seeds, the program ID, and a so-called PDA marker. That is just a string program-derived address. And this hash is a valid PDA if it does not lie on the AdWords curve, which you see on the right. Because otherwise, if it lies on that curve, there could be a private key associated with it. It would be still quite hard to find, but better be safe than sorry. So this hash is quite simple. There's actually once was a funny loss of funds bug on Solana with this, because the hash domain, collision domain of those seeded addresses, which I talked about before, collided with the hash domain of PDAs. I think we wrote a blog post about it. If you Google PDA Neodyme Solana, you will find it. But sorry for the derail. Exactly. So now we know how program-derived addresses function, but we want to check which funds are controlled by which smart contract. So what do we need? We need token accounts, so we know where all the money lies on the blockchain. We need those PDA derivations, and we need token prices. Token accounts are easy. Just pass some snapshot ledger using Agave Ledger tool or something else, and extract all the token accounts, put them into a database, done. Next, prices. They are also quite easy to get. Just use some API I wrote. I later found out that it isn't that easy because pricing of tokens is quite hard. You got a lot of wash-traded meme coins, etc. But you can filter that, it's doable. The really hard part is getting those PDAs, because they aren't materialized anywhere in the ledger. This information of PDAs on Solana is only available at the runtime level. So if you look in the Solana Explorer, you will see a pub key. You will also know that it's a PDA, because this pub key doesn't lie on the AdWords curve, but you won't know which program can sign for this pub key, and you also don't know how it's derived by its seeds. And there has not been a public database yet, so we set out to build it. How did we do that? Well, it isn't that complicated, actually. We just need to patch the runtime of the Solana validator. Most programs use a syscall, or two syscalls to be specific, to calculate those PDAs. Salt find program address and salt create program address. And they offload those hash calculations to the runtime, because it's cheaper to do it that way than to do it in eBPF. And luckily, we already had a patch-ready emulation of all Solana transactions. This serves as the backend of RiverGuard. It's a tool we built 2 years ago, which actually scans every live transaction that is happening on chain right now, and it mutates it according to known attack rules. And we check if, like, some basic checks like account owner checks, signer checks, self transfers are possible. You can check it out. It's free of charge, everything. But it was quite lucky for this use case, because we could quite easy patch the client. And then we just pushed the PDA seeds into a database, and now we got a database of all PDAs and their program derivations live. You can scan the code if you want. We launched this database public, so you can access it all the time. You can just put in the PDA, and you will see its derivations. It's quite cool. And we also built the teaser I showed you at the front, which program controls most of the funds. Are you ready? So it's actually squats. Most DeFi aggregators don't care about squats at all, because it doesn't earn money, or not that much. But it has the most funds locked in all Solana smart contracts. Next up is Lend, then Jupiter Perpetual, Squats v3. And it's quite interesting. If you click on that on the website, you will get to a next view. Oh, congrats to everybody who did it right. You will get to the next view, and you will see in which token mints are those funds actually stored. And if you click, for example, on USDC, you will actually get to the view where you see this token account is owned by that address, which is derived by this seeds. And this is super useful. For example, the first, we can already see by the seeds that this program apparently is a multisig. Next one is probably the multisig ID. After that, the vault. So we exactly see how does a program function, even if we don't know the source code of it at all. Some interesting numbers to wrap it up. I thought it would be interesting to share how much of a mint supply is actually locked in contracts, in contrast to it's held in normal wallets. So most value locked in PDAs is by USDC, and it's about 14.6% of the supply. Next up, by total value locked is pump, and about 50% of all pump tokens are locked in contracts. And for wrapped Sol, for example, it's nearly 73% of all those tokens, which are held in smart contracts and not in any wallets. In total, we roughly have 25 million different PDA-owned token accounts, so quite a number. And our database currently has about 104 million unique PDAs stored. The top program by most PDAs owned is the G2TIP distribution program with 27 million PDAs. This database isn't complete because we don't have historic data. As I showed you, it's a dynamic process of getting those PDAs. But it should have the most common and most recently PDAs in there, and it's still growing quite a lot. That's it for now. Thank you for listening. Follow on socials, etc., and hit us up. I will be back in the hallway. Thank you.
All right. Next, we have the lead formal verification team member from Seratora. Please welcome Pamina Georgieva. Come on up.
Great. Hi, everybody. My name is Pamina Georgiev. It's now Georgiev. It used to be Georgiou, so don't be confused. I'm the formal verification team lead at Seratora. And Seratora is a Web3 security company. And we, among other things, do formal verification. And I will use the next 8 minutes and 40 seconds to try to tell you what that means. OK, so when it comes to code security, most of the times, DeFi protocols use all kinds of things in their security stack. They start with reviews internally and externally, of course, right? They do auditing. They do a lot of testing, for sure. Ideally, they also do fast testing, so at least they cover, a bunch of inputs, and don't only rely on just a few unit tests. However, still, to find bugs with fast testing, it's a little bit, a game of chance. So sometimes you're lucky and you find the bug, sometimes you're just not. Now, at Seratora, what we do is we do formal verification. What that means is, that we actually try to mathematically specify the intended behavior of your code. And then mathematically derive those properties from your code with the help of so-called provers. OK, you might wonder, well, why do we need this in DeFi? There is real money at stake. And of course, you want to make sure that if you're handling money, that you cannot get wrecked. Otherwise, the trust is gone. And formal verification is basically the only way to guarantee any of that. OK, I'll attempt to give you a small code example. Please bear with me. You can see here a tiny little program. It's a vault program. The only thing that it does, you can deposit assets. And it will mint shares for you in proportion to the total value of assets locked in the vault. And you can redeem the shares with the withdraw function, and you should get your fair share. Simple enough, right? Now, when it comes to computation of values of assets to shares and shares to assets, most of the time you need to use multiplication and division there. Now, when it comes to division of integers, that means there's also rounding in here. In this case, I introduce a bug. Usually, you want to make sure that when you mint assets or when you redeem the shares and you get out the assets, you want to make sure that you do not overestimate the amount of money that you pay out to your users, because that would mean in the long run, the last person to withdraw cannot get their money back. So in this case, I do exactly this, and I seal the Maldive computation rather than rounding down, which means that we overpay by approximately 1 token. Now, a very elegant property to show such rounding issues is to actually show that that your share value cannot decrease after any user operation. So in terms of code security, you really want to make sure that for any public-facing functionality in your code, you make sure that that assets divided by shares, so the value of 1 share, cannot go down. And on the right-hand side here, you can see a partial implementation of a prop test. So I just wrote it as a test, a property-based test. And rather than using the division, I use multiplication, just to make sure that in the test itself, we don't introduce any additional rounding errors as well. And I actually wrote a complete test harness for this example, where I just generate random sequences of deposits and withdrawals from 1 to 200 steps. And I let this run for 100K test cases, and I did not run into a bug. So unfortunately, even with 100K passing cases, it does not necessarily mean that you're bug-free. And the only way to actually guarantee it is to formally verify it. Now, in Satora, we have a nice Satora verification language for Rust that allows you to actually write something that almost looks like a test as a formal specification. So you can see here the same, basically the same thing as for the prop test for the withdraw function. We're trying to assert that the share value cannot go down. Now, formal verification means we want to check all possible inputs to your function, and it also means we want to cover all possible reachable states of your program. In this case, our state is very small, right? It's just assets and shares. So we need to make sure we tell the prover that we actually start in a state where that is valid, so to say. And we already proved before that a valid state in this case means a solvent one. So we assume a state where we always have at least as many assets as we have shares. This is proved separately, but this is how we cover every possible state that is reachable as a starting state for the formal property. Then we take the variable shares and we say it's a non-det. It's a non-deterministic value, meaning that it can have any value that a U64, an unsigned integer, can have. And then we call the function that we want to verify. And then we assert our property. This is just a short macro, but it does the same cross-multiplication as we saw in the test before. And this way, we can now run the Satora Solana prover. It's open source. The link here in the QR code actually leads you to our docs if you're interested. It's super easy to install. It comes with a command line tool, as you can see here on the left side. And you can run basically rules that like the one you just saw. And as a result, you get a link, and that link contains the verification results. In our case, the verification result shows a counterexample. Now, a counterexample means we have one concrete state of values where our property is violated. So here we start in a state where we have 19 assets and 10 shares. Somebody wants to redeem 6 shares. And it turns out they get 12 assets rather than just 11, which would have been their fair share, thereby decreasing the share value. So the prover flags this immediately. This took about 30 seconds, if at all, with sending it off to the cloud and everything. And since we already know what the bug is, we simply fix it. We basically floor the Maldive in the withdraw function. And if you want to take a look, I actually implemented a few other properties as well. You can scan the QR. It will show you the rule report as we usually do it at Satora. And of course, that was a very, very small example. but we did formal verification projects for quite some big names that you might have heard about already, such as Jito, Camino, Squats, Manifest, and also some work with the Solana Foundation itself. And we also do more than just formal verification at Satora. So Satora is really, we're a fully fledged Web3 security company. We do audits, we do design reviews, we do operational security. We help you with any security needs that you might have. And if you currently have any security needs, I just wanted to do a quick shout out for Arita's security subsidy program. They are funding up to $1 million for Solana builders when it comes to security, and Satora is part of that project. So if you want anything from audit to formal verification, please check it out. Thank you.
Thank you, Pamina. All right, so everybody, we'll take a short break. Everybody, please come back at 5:45 p.m. See you then. Thank you.